right, so the plan today is to do Eigrp just like we did RIP yesterday. Basic initialization, authentication, filtering using ACL's prefix list. It's not going to take me as long as I did yesterday because a lot of these things are pretty much the same. I am going to do one extra thing with a couple of extra things with Eigrp. One is metric calculations. And the other thing that I'll also do is leak maps. Actually, leak maps and route summarization will do together. All right, that's the plan for today. And depending on how we're doing on time, we might get into OSPF as well. Any questions about it so far? You guys were okay with yesterday? All right, so let's get started. Same topology as yesterday's, nothing has changed. The only difference is I'm going to be running Eigrp on it rather than running RIP on it. So let me see the topology from yesterday. The same topology. I'm just going to be running Eigrp on it. So what I'm going to do over here is I'll copy this. Okay. Yeah, no pressure, man. I showed all my tricks yesterday, so let's see what happens today. All right, so let's go ahead and take a look at Eigrp. In terms of the topology, I'm going to use the same topology that I used yesterday and build up on top of it, run Eigrp instead of running RIP. So we looked at RIP and the way it ran RIP. I'm going to do the same type of things with Eigrp and try to compare and see how the two different protocols are different. Besides Eigrp establishing a neighbor relationship and then exchanging routes rather than with RIP, it just sends the updates on a regular basis without establishing any neighbor relationships. Over here with Eigrp, what's going to happen before they exchange any of the neighbors? You have router 1, router 2. The first thing that they do is send hello packets to each other, establish a neighbor relationship. Once the neighbor relationship is established, then they start exchanging the routes. When they exchange the routes, they send the routes across. The other router will acknowledge that, hey, listen, I got your route. Because router 2 has acknowledged the route, router 1 is not going to keep on sending the same route over and over again to router 2. Instead, on a regular basis, which is 5 seconds by default, it is going to send a hello packet. Hey, listen, all the routes that I told you about are still alive. Says thank you very much. So on a frequent basis of 5 seconds, I'm going to send a hello packet. If router 2 does not hear from router 1 for 3 intervals, which is basically 15 seconds, it'll say, listen, this router seems to be dead. He's not receiving any of the route. I'm not receiving any hello packets from him. All the routes that are received from router 1, I'll pull them out of my routing table. Everybody okay with that? Basic differences in the way RIP and Eigrp work. The other thing that also is different is the maintenance of the second best routes, or not the preferred routes. I have router 1, router 2, router 3. Let's say all the links are of equal bandwidth. They're the same type of links. Router 1 sends a route over here, let's say network 1.0.0.0 to router 2. Router 1 also sends the same route to router 3. Router 3 also propagates network 1 to 2. So now router 2 has got the same route from both sides. Router 2 receives a route saying, I got 1.0.0.0/8. Eigrp has a notation of D. via R1. He also gets another route from 2. It takes both the routes and puts it into the topology table. Both the routes that are received are put in the topology table. Once a route is put in the topology table, Eigrp runs an algorithm called the DUO, diffusing update algorithm, to figure out the best route. I haven't put the metrics over here. It would find out one metric is better than the other. And based on that, it would put the best route into your routing table. That route that is put in the routing table, let's say it's via 1, is known as the successor route, the best route. The second route that did not make it, that's not the best route, is still maintained in your topology table, known as the feasible successor. One second, guys. Is it possible when someone asks a question that you can repeat the question and answer it as if we can't see what the other people type? Absolutely. Right now, nobody is answering any questions. So like I did with you, I will do the same thing with everybody else. All right. So far right now, nobody's asked any questions. So the routes go into the topology table, the dual algorithm is run, the best route gets put into the routing table known as a successor. The second best route is maintained in the topology table known as the feasible successor. Just in case, let's say something happens to this link over here between router 1 and router 2, it goes out. After 15 seconds, router 2 knows that router 1 is dead or reachability is not there. It does not need to do too much. It doesn't need to ask R3 for the route. It immediately takes a route from where? The topology table, takes a feasible successor and puts it into your routing table. It now becomes a successor. So that's some major differences between RIP and Eigrp in terms of the way it works. Not the configuration part of it, but at least the actual working of it. So to recap, in Eigrp, when two routers talk to each other, the first thing that happens is a neighbor relationship is established. Okay. Once the neighbor relationship is established, they exchange the routes. Acknowledged. That means, yes, the other guy got the routes. Okay. Once the acknowledgement takes place, from that point on, hellos are sent to maintain the relationship. So that, like a keep alive, so that R1 and R2 know about the routes. The way the routes get propagated, the routes go into what? Into the topology table. Runs the algorithm. If I have multiple routes, the best route gets put into the routing table. What is that route called? What is the best route called? The successor route. And if you had a second best route or a third best route, those routes remain in the topology table. And these routes are known as feasible successors. Later on, if you get a chance, we'll also talk about the feasibility condition, but feasible successors is what they call right now. Is there a max number of routes it can store for a single network? Think about, from a practical perspective, the question that you asked, it's basically the different ways of getting from point A to point B. How many different ways would you have from point A to point B within an IGP type of network? Not too many. So maybe there's a theoretical limit, but practically it shouldn't be there. I think the same question asked by Robert. We'll talk about that. Let me finish the basic stuff. I'll go over the feasibility condition and how the routes get propagated into your routing table as well. What makes a route a feasible successor? We'll take a look at that. Don't worry about that. All right, so everybody's muted right now. So, all right, so let's go get started with the actual configs and see how it works. And then if we have any problem, we'll come back to it. So R1, R2, R3. This is the topology I'm going to set up. Actually, I'm going to set up Eigrp in all the different places. So this is my topology over here. Router 1, router 2, router 3. I want to set up the same type of things that we did yesterday, but the only difference is today what I'm going to do is I'm also going to set up these links over here all the way across to the serial links. So I'm also going to do this link for Eigrp today. We're going to do the serial links between 4 and 5. We're going to do a link between 5 and 6. And we'll do the link between 4 and 6. So we'll do all the links over here. All right. So with that in mind, let's get started. Let's bring my secure CRT on. Bring my devices up. R1, R2, 3, 4, 5, 6. All right. So router 1. Right now, I'm not running any routing protocol, but my interfaces are there. So just like yesterday, find my networks, 10.1.10, 10.1.20, 10.12, 11.1, so on and so forth. Now, the first thing that we discussed yesterday was the advertising of the network. So basic initialization. You guys remember this? In RIP, you could only do the major networks. In Eigrp, you have the ability to enable Eigrp on all the subnets of a major network like RIP. So technically, if I wanted to enable all the interfaces under the major network 10 under Eigrp, I would say router Eigrp 100, and I would say network 10.0.0.0. What would that do? By putting the network statement like that, it would work exactly like it worked for RIP. What do I mean by it would work just like RIP? Anything that is underneath the 10 major network, it would enable Eigrp on all those interfaces. Good so far? But the good thing over here is you do have the ability, the flexibility of doing it per interface. So it brings in the wildcard mask over here. So if you want to do it for different interfaces, not all the subnets, you do have the capability of doing that. So for example, I could say 10.1.1.0, 0.0.0, 255. So it means what? Anything that is in the 10.1.1.0 network would be enabled. I could also technically do this. Put the IP address of the interface and say 0.0.0.0 means what? Enable it on this interface. Again, this is not the advertising of the network. I'm not advertising 10.1.1.1. I'm basically telling over here is, what am I telling over here? Which interfaces should be enabled in Eigrp. So we'll do both. I'll do different ways over here. You can do the major network. You also have the ability to use a wildcard mask to specify which interfaces it should be enabled on. So let's take a look at that example. Yeah, you can do 0, 0, 0, 0. Also, that would allow you 255, 255, 255, 255, which would allow you to enable it on all the interfaces. Remember, we did that in RIP as well yesterday. Okay, let me show you the different ways of doing it. So I have this network over here, set of networks. Let's do on 10. I only want to enable it on 10.1 and 10.12. So I could technically do this. Okay, for the 11 network, I can do this. I'm just showing you different ways of doing it. For the 101 network, I can just say this. Do you get my point? So you have the ability to enable Eigrp on different interfaces using different mechanisms. 0, 0, 0, it's a wildcard. So wildcard would be what? 255, 255, 255, 255, means I don't care about any. One 0, 0, 0, 101 is the major network, right? Any subnet of 101 would be enabled. So 101.1.4, 5, 6, and 7, all of them. Anything, any subnet of 101. Is 101 a major network? Yep. So anything that's a subnet of 101 will be enabled. Got it? So different ways of doing it. So I didn't need to, like in RIP, remember, if I didn't want 10.1.2 to go out, over here I have the ability to not even enable it. You get my point? Whereas RIP, I didn't have a choice. In RIP, how would I do the same thing? The only way I could do it is router, RIP, version 2. Yeah, with the, if I didn't want to do it, but in terms of the network statement over here, how would I do it? I had to do this. There's no other way of doing it. Only the major networks. That's your RIP. Over here, technically, I could do the same thing. I could do the same thing in what? This would also work in what? This would work in Eigrp as well. If you don't want to advertise 10.1.2.0 in RIP, then you don't have a choice but to do it with the distribute list. But over here, I do have the ability to do that. You guys understand that? I'm going to take the RIP off, but I just want you guys to compare the two and see the different ways I could do it. Good so far? Let's not advertise 10.1.2, so I'll do it like that. Now notice over here, I didn't specify anything about auto summarization, right? What's the default? It depends on the iOS. Okay? The older iOS is like the 12.x iOS, it was on, just like RIP. The newer iOSs, it is disabled, so no auto. You get my point? So be careful with that. When you go and work on an iOS, you need to work with the defaults of different iOSs. In 15.x, no auto is the default. Prior to 15.x, it was auto summary the default. So 15 and onwards, no auto. Prior to that, auto. Let's do auto summarization over here. We will do auto summary. The reason I want to do auto summary over here because I want you guys to see that auto summarization works exactly the same way where in Eigrp the way it worked on RIP. So I have that turned on. Let's go to router 2 and enable Eigrp. So again, show IP route includes C. Set the autonomous system. I will do auto summary because I want you guys to see it. Network statement, I'll say all the 10 networks. I'll say 22. I'll say 150.5. And I'll enable it on the 23 network. Good, everybody? Now, show IP route, Eigrp. You will notice that I am getting the 10 route. Didn't I do auto summary over here? It's creating a null route for the auto summary. So although I'm doing the auto summary, I'm still getting 10.1. Why am I getting 10.1 if this one has auto summary turned off? Again, the same reason. You guys remember what the reason was or how auto summary worked? Because I'm sending 10 over the 10, same major network, I would get it as 10.1. At the same time, if I were to have 11.1 over 10, auto summarization is turned on, I should receive what? 11 over here. So auto summarization does not change a bit in what? In Eigrp, it still works the same way. So if I go to router 2 over here, you should see the 11 network as a summarized network. Do you guys see that? But 10.1 is coming in as a subnet. I personally don't. As a habit, not today, for the last 15, 20 years, all I've been doing is router RIP or router Eigrp, no auto summary. Redistribution, when we do redistribution, we'll do that at the time. Let's focus on this for right now. Anytime you do any type of summary in Eigrp, in order to advertise a route in Eigrp, you need to have the route locally present. So if I'm summarizing 10 and sending it to somebody, I need to have the route locally present in my own routing table. That's the purpose of having a route over here, a summary route, so that in order for me to send it, I would have it locally. You get my point? So anytime, any Eigrp, I want to summarize something, I'll create a local route so I can send it out. That's why the summary route is there. That's an Eigrp thing, not RIP. Yesterday, we did not have any null routes. So over here, we do have null routes for the auto summarization. It creates a local route in the local routing table for whatever I need to advertise. So because I'm doing auto summarization, I'm going to be advertising 10.0.0/8, right? So because I'm advertising 10.0.0/8, it needs to be locally present, and that's what it creates a fake route, null zero route, but it needs to be there so I can send it out to somebody else. You get my point? So for me to advertise a route to somebody else, it needs to be present in the local routing table, And that's what the null route does. It creates a fake route so that it can be in the local routing table so I can advertise it to somebody else. Good, everybody? So 10.11.00 is not advertised. This guy? Oh, this is received. This would be a summary route or a null route on R1, the originating router. It was summarized on R1. So if I go to router 1 and I do show IP route, it would be in your routing table as a null route on router 1. Because the originating router of that one was R1. Got it? So we took a look at auto summarization as well over here. We looked at your network statement over here. So basic initialization, we had done network statement, auto summarization, and passive interface. We need to do passive, but the first two, you guys are okay with the network statement and auto summarization? These two things over here. Let me write it down for the thing over here. Auto summarization works exactly like auto summarization in RIP. All right, auto summarization works exactly like auto summarization in RIP. It will auto summarize to the major network boundary. That's your class boundary. If the network is being sent on a different major network, the same thing that we discussed yesterday in detail, it still is in effect over here. All right, so R1, R2, and R1 and R2 we've set. Now that we've seen the auto summarization part of it, what I want to do is do no auto summary, and because it's changing the routes, it's going to resync the neighbor relationships. That's what I love about Eigrp. I don't need to do that clear IP route type of stuff. On router 2, I had enabled it on all the interfaces, including the 23. 23 is the link between 2 and 3. So right now, let's go ahead and enable it on 3, 4, 5, and 6. So we'll have a full Eigrp topology over here. So I'll write them in your notes as well once we're done with that. Router 3, find out the first networks first that I want to advertise. Make it simple on yourself. Router Eigrp 100. I don't need to do no auto summary because the default is no auto summary. Network 10. Network 172.16. Network 192.1.23.0. It should establish a neighbor relationship with R2 and 34. I'm running it on that. As soon as R4 gets up, it will have it. So I will copy this config for you guys. Into your notepad, R3. And while I'm at it, I'll also copy your R1 config and R2 configs. So you have a full config in your notes. That's R1. Similarly, you will have R2. All right, so 1, 2, and 3 are done. Let's do 4. Show IP route include C router Eigrp, no auto summary, it's just a habit. Now on R4, you also have two serial links, 4 to 5 and 4 to 6. I'm going to enable it on those interfaces as well. Show IP route Eigrp, so you see a whole bunch of different routes popping in now. Show run. The video is lagging? That's my speed, man. No, sometimes it does lag. To R5. That's my 10 network. That's my 55 network. Those are your 105 networks. I have 3 or 4 of them. This is the 45 network. The neighbor should come up. And 56 would be the other one between 5 and 6. Get this into your R5 and R6. So my whole topology is set up after this. Ten, 66, 106, 192.1.46.0. Zoom went down yesterday? Really? Did we just bombard them yesterday? Wow, big network now. This is done. We talked about auto summarization as well. Now, passive interfaces. Difference. Help me out with RIP passive interfaces and then we'll compare it. What do passive interfaces do in RIP? Stop what? Sending multicast updates. Right? Sending multicast updates. I can still send unicast. I can still receive. Right? Clear? Eigrp is different. Only use passive interfaces. Let me write what it does first. Stops sending and receiving multicast and unicast updates on an interface. Okay, sending and receiving multicast and unicast. So if I don't want Eigrp running on an interface, that's where I would do running in the sense I don't want to send or receive updates on that interface. That's where I would do passive interface. So Yesterday, we had two usages of passive interfaces with RIP. Let's recap them. I used passive interface in RIP yesterday for my LAN segments. LAN segments, what do I mean by LAN segments? No other routers, like a dead end network with just PCs on it. So I used passive interface over here. Is it still? Is it better? Okay. And then I also use passive interface on the router to router segment in case I had other routers over here and I only wanted to send updates from 1 to 2. I did passive interface over here. And then I did the neighbor statement, because in RIP, if I just do the neighbor, it does what? Just sends the unicast. It does not stop the multicast. So I need to do the passive to stop the multicast. Yeah, LAN segments are PCs, dead end devices. Dead devices like a stub network. There's no other routers over there. But I still need to have this interface enabled so that this network is advertised to other people. So I still need to run Eigrp on it, but I don't want to send or receive any Eigrp updates. Would we need neighbor statements on both neighbors? I'll get to that. The answer is yes, but I'm going to explain that in a second. So these are the different places that I would do what? Passive interfaces, this was with RIP. Eigrp works differently. When you do passive interfaces, stops sending and receiving multicast and unicast. So if I did passive interface on this one, even if I do neighbor statements, passive means nothing. So this interface would not be able to talk Eigrp then. So do not do passive over here with Eigrp. Passive is only for what? Your stub networks. So in my case over here, let's say, hypothetically speaking scenario, I want to do what? Eigrp unicast on this segment. All right. The other segments that I have over here, my loopbacks, the different ones that I have. I'll just put 4, but I know I have more than that. Okay. On these segments over here, I want it to actually not send or receive updates. Would we need regular statements on both? Yeah, I'll talk about that in a second. So I would do passive interface over here. Where? On these interfaces over here. Not over here. If I want Eigrp unicast, I'll show you how to do it. So let's go to router 1 and do that. Router Eigrp 100. And I can still do this. Passive interface default. It will bring my neighbor relationship down with router 2. But then I'll say no passive E0/0. It'll bring it back up. So I can still do the same thing. Basically, I've passived all my interfaces except for E0/0. That's still there. But now E0/0 is not a passive interface. It's a normal Eigrp interface. But on that interface, I want to do the neighbor command. I want to do unicast. So yesterday, when we did that in RIP, if I wanted to do unicast, How did I do unicast in RIP? Router RIP, I would do passive interface E0/0. If I didn't do that, what would happen? If I did not do E0/0, it would continue to send multicast, plus I would need to put the neighbor over here. So two commands, right? One to stop the multicast, the second one to send the unicast. Let's try to do the same thing in Eigrp and see what happens. Neighbor 10.12.12.2. I'll press enter. I want you guys to see what happens. Tells you incomplete command. So I need something else besides the neighbor command to make it what? A neighbor. What is that? Oh, some interface. So when I do a neighbor command in Eigrp, I need to tell it which interface do I want to do this on, because it's going to do a stop, it'll stop the multicast update on that interface. So it's only going to send unicast updates. But I need to tell it what interface. So in my case, it's Ethernet 0/0. So the neighbor command in Eigrp is the neighbor IP address and then the interface that you want to stop multicast on. It's different than RIP. Okay, and you'll notice over here it says neighbor is down with the other guy because the static pair replaces the multicast. Now static pair means unicast. Unlike RIP, where you can send unicast updates one way and multicast the other way, Eigrp does not work like that. If you did a static neighbor on router 1 towards router 2, it needs to be unicast the other way around as well. You get my point? And that's something that somebody was asking earlier on as well in terms of do I need to do it on both sides? Absolutely need to do it on both sides. So we'll do the same thing on R2. Router Eigrp 100, passive interface default. Now all my neighbors will be coming down, including the one towards R3. No passive. I need to say no passive E0/0. I'll leave it off. I want you guys to see that. So right now E00 is still passive, right? That's towards R1. If I do a neighbor, did I do the right neighbor over here? Yeah, 12.2. 10, 12, 12, 1, Ethernet 0/0. So I put the Ethernet command, the neighbor command in there, but I have not undone the passive interface over here. So the neighbor relationship is not coming up. Why not? Because I still have the passive interface for E0/0. The passive basically says no unicast, no multicast on this interface for Eigrp. So I definitely need to do what? No passive. Now my neighbor relationship should come up. And it's a static neighbor relationship. So how do I do passive in unicast, unicast in Eigrp, router Eigrp 100, neighbor, now this is on R1. All right, so on router 2 again, it's also E00. Good, let me write that down for you guys. So what's the question? On an ether segment, we configured 2 routers with neighbor, the neighbor command, and leave out the third. No neighbor relationship with the third. It won't establish a neighbor relationship. If it doesn't establish a neighbor relationship, it's not going to get any updates. So in Eigrp, how do I do passive? Exactly the same way. It works a little different, but same thing. Passive interface, the commands are the same. I'll do a default and no passive interface E0/0. This we do on router 1, and if I want to do the same thing on router 2, router Eigrp 100, passive interface default, no passive interface E0/0. You get my point? So unicast and RIP, passive interface should be clear. As I said, it's much easier now today because yesterday we had a detailed discussion about how it works with the basic initialization. We took a look at 3 different things. I'll bring that up from yesterday. The default question, yeah. I had, let's say I had 5 or 6 interfaces over here. I have router 1 with multiple interfaces. All these are LAN segments, and this is the only segment that I have another router on. How would I do passive interface? Let's say this is interface E00, this is E01, E02, E03, let's say E10, and E11 on my router. How would I go about doing it? The way I would do it is by doing what? Passive interface E01, E02, E03, so on and so forth. Now, if you're getting paid by the hour, I would definitely do that. So rather than doing that, I do passive interface default, which basically puts passive interface on all my interfaces, but then I open this up. No passive E00. Make sense? Yeah, I have worked as a consultant. I don't do all these shortcuts over there. Good, guys, everybody okay with this? Absolutely is, absolutely is. Passive interface default is a good practice. Why? It's not just I'm saving myself time, it's also from a security perspective. Tomorrow, let's say a new interface comes up, it's not automatically open for another routing protocol or Eigrp. So this way I'm controlling it as well. Yeah, security. Totally agree. Good, everybody? So you guys are okay with the basic initialization of Eigrp? You understand every small thing, the way we compared RIP and Eigrp as a protocol. How is Eigrp different? You guys are comfortable with that? All right, good. So the next thing I want to take a look at is authentication. How do I do authentication in Eigrp? Let me save this file as well. Save it as day2. All right. The next topic over here is authentication. With, what do you call it? With Eigrp? Or are you talking about OSPF? See, the Eigrp, you don't need to do, what do you call it? Let's say I'm running frame relay and Eigrp together. Generally, what you do with frame relay, you would say the frame relay map statement along with the keyword broadcast. So that would also take care of it. But if you're talking about OSPF, then it's a different story because OSPF runs into those interface types and that becomes an issue. But with the Eigrp, normally the frame relay command with the broadcast is good enough. But with the OSPF, it takes on a completely different meaning. So now authentication, it is per interface, just like in RIP. It still uses just like yesterday, everything is the same with the keychain. The difference, Eigrp only supports MD5. It does not support clear text, or I should say, does not support clear text. Having said that, that means there's only one authentication mechanism on the interface. Although there is only one mechanism on the interface, you still need to set the mode as Eigrp. Why is that? In Eigrp, when you set the mode, you turn on authentication. That's what somebody was saying yesterday. The mode turns on authentication. I told him, no, that is not true with RIP, because RIP does not need the mode. Here in Eigrp, to turn on authentication, you need to have the mode. You guys okay with that? So for Eigrp, you still need to set the mode. Now the Eigrp authentication statement is a little quirky, and I'll explain that to you guys. I'll try to put it in English so you guys understand it a little better. So how do I do authentication in Eigrp? Let's say we want to do it over here for Eigrp. We'll do it between, there's no text, so I'll get rid of this. Okay, so I'm going to do MD5 on this guy now. 2 to 3, 3 to 4, let's say. All right, so how do I do it? Let's do router 2 first. Same concept, keychain, ABC, key 1, key string, Cisco 1, 2, 3. Now, when you go to apply it, router 2 to router 3, the interface is E01. Okay? So interface E01, IP, authentication. Generally, what do you say? Mode MD5? Right? Isn't that what we did with RIP? RIP, we did what? IP RIP, authentication, and we're used to, as techies, to say mode and then the whatever the mode you want to use, right? In Eigrp, because Eigrp can have multiple autonomous systems, you need to put mode for which AS number are you going to do it for. You get my point? Let me write it down. Let me do this over here. I'll show you that as well. So if I go to router 2, create the keychain. IP authentication, and the reason I'm doing it like that, so you guys see, you don't have too many options. The only thing that you have is Eigrp and the AS number, so you can't go wrong with this. And then you specify the mode. There's only one. Now the way I read it is differently. Read it in English. The programmer forgot to write it over here. The way it reads is mode for Eigrp 100 is. So it's IP authentication mode for Eigrp 100 is MD5. Don't put the for and the is, but that's the way it is. So you put the mode over here. The actual mode is over here. But you need to specify, because on the same router, same interface, you have the ability to have multiple what? Eigrp AS numbers, Eigrp 100, and that's how it goes. Okay, you can just use a question mark to do it, but that's why I did the question mark, just so that you guys understand it's not that tough to remember. There's only one option for each. But the way I remember it is this. Similarly, when I do the keychain, I would do the same thing. So I would say IP authentication, keychain is ABC, but for what? Eigrp 100. So again, you're going to say what? Keychain for Eigrp 100 is ABC. All right, so let's do that. I've done one, and as soon as I put it in, actually, let me take it off. I want you guys to see something over here. So I haven't done the authentication. Took it off, my neighbor is up, right? I have created the keychain. My neighbor is up. I go onto the interface and I say IP authentication keychain for Eigrp 100 is ABC, because I created ABC over here, I believe. Yeah, ABC is the name of the keychain. Done. As soon as I put the command in, my neighbor is still up. Didn't affect my neighbor. You guys see that? Oh, I have the keychain applied, but it's not bringing down the neighbor. My neighbor relationship is still up. My hellos are still coming and they're valid. How come? The reason is, in Eigrp, the authentication is only turned on when you set the mode. Unless you set the mode, the authentication is not turned on. And that's what somebody was pointing out yesterday. That was for RIP. RIP does not work like this. So as soon as I put this command in, now authentication is on. Now it's not working. Why? I haven't configured the other side. So on the other side, I'll create a keychain. III, just a name, key 1, key string, Cisco 123, go onto the interface, IP authentication, mode, Eigrp 100 is MD5, IP authentication, keychain, Eigrp 100 is III. As soon as I do that, the neighbor will come up. Good, everybody? So you have mode and MD5, you don't do it like that. Doesn't matter which order you do it in, as long as you have both. But understand, the mode is the one that actually turns on the authentication. You can do it in any order, but if you want authentication to work, you need to have both in place. All right. So mode, Eigrp 100 is MD5, IP authentication, keychain, Eigrp 100 is whatever you called it. And on R3, I did it using a different keychain name. I did that on purpose so you guys understand they are locally significant. And as you guys can see, authentication is still interface specific. Got it? Everybody okay with this? That's authentication for you guys. All right, brilliant. We're chugging along today. Everything, the keychain concept, the rotation, everything remains the same. All right, good, good. So we're done with these two things over here. In the basic initialization, I'll just write that down. We did the network statement. We did passive interface, auto summarization, and passive interface. And then authentication. This is where we're at right now. Now filtering. I'm not going to do anything over here. Can you use different keys on a multi-access network for different neighbors? You can use different keychains on different interfaces. On the same interface, you'll have the same keychain. On one interface, you cannot do different ones for different neighbors. It's per interface. For different interfaces, you can do that. Filtering. You guys remember filtering yesterday? Sub-interface from the perspective of Eigrp is treated as an interface because it's an IP interface. So you see it as a sub-interface, Eigrp sees it as an interface. So for you, wherever you assign the IP, Eigrp treats it as the interface. So for you, you might see it as interface E0/0.1 with an IP on it. Eigrp does not care about E0/0.1. It's on this IP-based interface. Does that make sense? So wherever your IP is where you would do these type of things. Now, do you guys remember ACLs and a prefix lists that we discussed in detail yesterday? You guys had fun with those 007 ACLs? The concept is exactly the same. Nothing different. Even the application is exactly the same. So I'm not going to lecture on them again. It's the same thing. Let's just do it again as a review. Which ones do I have over here? We have we'll do the ACL for odd even. We'll do the ACL for that, the bit-based match. And the prefix list, we'll do it for those oddball, what do you call it? The masks. Okay, let's do that, and then we'll take a break right after that. I need to figure out where are those odd and even type of things, and then we'll do it based on that. Show IP interface brief. I believe this one had the odd evens. Yep. So you guys remember this? Help me out today. Pop quiz. How do I block the, let's block the even numbers right now on R4. If I go to 4 right now for the 172s, I have 1, 2, 3, 4, 5, 6. I want to block the evens in the 172-16 range. How would I write it? Let's say on R4 inbound, not 255, 255, because I want to do it for what? The first two octets being 172.16. So I would create the ACL as access-list 1, deny 172.16. I want to block evens, so 0, match the first two octets, 254.255. Don't forget, you need to permit the rest. How do I apply it? Router Eigrp 100, distribute-list1 in E0/0, exactly the same way that I did for RIP. That's why I said, now that we know it, it's much easier to do. Now, the good thing about Eigrp is it will resync automatically. So I don't need to worry about doing what? A clear IP route thing. Access list 1 permit 172.16.0.0. Is that a question or just putting it up? Yeah, that's right. The network portions, right? What is the mask? The mask would be 00254.255. And that's what I put over here. Got it? And then the permit any. What about the .6? It's going to be blocked, right? Because .6 is an even number. So if I do show IP route Eigrp, actually just do up arrow and I should have that. So 1, 3, and 5 are there. The other ones are blocked. Good so far, guys? Let's do the, no? So you want to take a look at the 172.16? The mask should be 254. Why should the mask be 254? Were you here yesterday? Okay. What does the mask 254 mean? Not the common bits. What is it 254? If I convert that to binary in terms of the wildcard mask, 254 means this. Agreed? No. So over here, what it basically means that in this octet, the third octet, I am not matching any of the first 7 bits. I don't care about these 7 bits. 1 in a wildcard means don't care. So far, so good. What is the significance of this 0? This is 254, by the way. What's the significance of 0? What does 0 mean in a wildcard mask? 0 means match. Agreed? That means we're only matching or looking at the last bit. Why the last bit? Because this is the bit that will determine if the net number in this octet will be an odd number or an even number. So if I put in my network statement 0, so that means I'm matching I'm going to do a deny only if this number is 0. If this number is 0, this octet is going to end up being an even number. And that's what I want to match. And that's the one that I want to block. You understand that? So I'm not matching 2. It doesn't give you 2 matches. Don't look at it like a subnet mask. It is not a subnet mask. It's basically telling you which bit to match. So it's actually matching on this bit. Anytime this number is a 0, I'm going to do a deny. That's what I'm saying. I don't care what's in here. How do I say I don't care what's in here? Because of these ones. Ones means don't care. Understood or no? 0 means match. 1 means ignore. I'm matching this bit to be 0. If it's 0, I'm going to deny it. If it's not 0, I'm going to allow it. So any odd number, what is this bit going to be? this bit is going to be 1. And if this bit is 1, this number ends up being an odd number. Why? You guys remember this? It's, yeah, we spent a lot of time on this yesterday. If you were here yesterday, we actually went through this. So this is the bit that determines the sex of that octet, meaning odd or even. Cool? Yeah, I agree. But again, at the same time, you have if you know how they work, you can really do some funky stuff with it. So that's the first one taken care of. We did the odd and even. There was another one, the 172. Did I write them down or no? I created them. I should have them in my notes from yesterday. If I do, that would be great. I'll just copy paste it. This is your odd evens from yesterday. I showed it to you, but I typed it in myself, so I would need to type it in again, and we'll do it over here on R1. Oops. We'll say loopback 401, 150.5.50. Or 55, we'll say 50.1. We had 74. We had 80. We had 90. We had 100. We had 150. Let's say 175. Oops. Say 200. 202. And let's put 218. All right, router Eigrp 100 network. Good thing is they all fall under 150.55. So if I go to router 2, show IP route Eigrp, include 150.55. So I have 50, 74, 80, 90, 100, 150, 175, 200, 202, and 218. I want to do the block. Let's do on R1 outbound. So again, access dash list 1, deny 150.55.74. The same thing that we did yesterday. I'm not doing anything different today. One out E0/0. Now give it some time because it will resync automatically. What design? Nothing. It's a way of teaching you the significance of the bits. Personally, I've never done it in real life. I agree with it, but it's a good tool to learn about how the actual bits work in an ACL. To answer your question, what design would use the odd even? Objective? Bad design. but it's a good way of learning of how the bits work, that you don't have to have contiguous bits. So it's a good way of learning it. So now that the sync has taken place, if I go over here again, you'll see that 74, the 90, the 202, and 218 are gone. Good, everybody? Deeper understanding, yes, correct. That's what it is all about. Even this one is a little bit more sophisticated because you're now checking bits all over the place. It's not just in one place. All right, let's do the prefixes and we'll take a break. I think prefixes, I had those different networks on this particular device, but I don't remember now. Yeah, 150.5 had those 24, 26, 27, 28, 29. Let's do prefixes on R2. Yeah, a lot of, it used to be a lot, very common thing to do on the CCI exam. All right, so on R2, I'm going to block, let's say I want to block the 150.5 networks that have a mask of, let's say, greater than 26. I want to block what? The 150.5.00/16 networks, anyone that has a mask of greater than, let's say, 26. How would I write it? IP prefix dash list, whatever you want to call it, deny 150.5.0.0/16. You guys understand the significance of that /16 over here? That's your wildcard mask. That's basically telling you to match the first 16 bits in your network portion. The question says mask greater than 26, right? GT. So what do I write it over here? G26 or 27? And then your permit statement for 32. Greater or equal to, yes. GT is greater than. There's no there's no GT operator on the iOS. So once I create the prefix list, just like on RIP, the way you apply it is exactly the same. Let's do it from 2 towards 3. Type O, didn't get that point. Type O meaning? Okay. So this is done on R3 now. Do show IP route. Eigrp include 172, no, not 172, 150.5. So denied greater than 26, which is 27, 28, 29. So I'm only seeing 24 and 26. Working perfectly fine. So if I had to write these statements for filtering, Eigrp filtering is identical to RIP. Just read the notes of RIP. The only thing that I would do differently is under Eigrp, I would say distribute dash test under Eigrp. Other than that, it's exactly the same. Or You get my point? So I'm not going to redo this because it's exactly the same. I'd rather do other stuff in the time that we have. Good, guys, everybody okay with this? So I've knocked out another aspect of this that we had to cover. So filtering is done. So we're at this point over here. Good time to take a break. We'll knock this out. When we come back, we'll finish up on Eigrp. We'll definitely try to get it to overspeed.